Platelets are tiny blood cells that help prevent bleeding. We have billions of them in our body. As part of Science Foundation Ireland's AI for Societal Good Challenge, scientists at UCD have discovered that the information these blood cells carry, combined with powerful AI, can help doctors diagnose preeclampsia, a condition that occurs in pregnancy. In a small number of cases, it can lead to early delivery of the baby. I've come to meet with AIPREMie team lead, Professor Patricia Maguire, to find out more. Patricia, I'm always fascinated by academic names for projects. Can you tell me what AIPREMie stands for?
So AI is artificial intelligence, and preemie then is for preemie births, so to prevent preemie births. That's what the project is all about. So preeclampsia is a really complicated condition, and people have looked for years and years to try and find new diagnostics. In my lab, we found how to reinvent finding new diagnostics in the blood. And we do that from the power of platelets, these little tiny cells that are in your blood. When you cut yourself, platelets are the first responders. They're like the ambulances in your blood. They come to the site of injury first, and they help to clot your blood. But actually, they do so much more. They're actually like immune cells. They carry a cargo of information inside them. And when they get to the site of injury, they actually, if you like, explode and burst and push out all that cargo. And that cargo, it helps that wound to heal and full tissue regeneration. Once you know how to get that information out of the platelets, you can find, if you like, barcodes of different diseases. And we've done this in different inflammatory diseases, and one of them is preeclampsia.
So what exactly is preeclampsia? And how can AIPREMie make a difference?
Preeclampsia is a condition of pregnancy that affects about 1 in 10 pregnant people. It's characterised by high blood pressure and by protein in the urine, often in women who are clinically very well until they actually get the diagnosis. And it can present in different ways. In some people, it affects the mother with high blood pressure and proteinuria and can go on and affect her liver, her kidneys, her brain. In other people, it just affects the baby, where it can cause the baby to be small or to have blood flow problems, and unfortunately sometimes can cause stillbirth. It's a very difficult condition to actually diagnose, and the only real treatment is delivery. But sometimes that means that the baby's being born preterm and has the risks of prematurity.
Preterm, we're talking anything from 30 weeks before?
Actually, I've looked after people who've developed preeclampsia at 23 or 24 weeks, literally at the thresholds of viability, where we have to have important discussions with the family, with the neonatologists, and ourselves as obstetricians to discuss what's the right thing to do here. Because this is a woman, if she's not treated by delivery, may become very unwell. But unfortunately, the delivery means that the baby could be very sick, very premature, and some of them do not survive.
So Mary, what is the current gold standard in diagnosing preeclampsia?
So the classic definition is that it's a combination of new onset high blood pressure and protein in the urine. Then what we do is a series of blood tests called preeclampsia bloods, where we check the liver, the kidneys, the coagulation system. But those tests haven't really changed since the 1960s. And there isn't a good quality rapid test at the moment that will rule in preeclampsia. It will tell us, yes, you do have it, and this is what it could be. The other difficulty is trying to tell people what the prognosis is. How quickly are they going to get sick? How long do they have? Because in pregnancy, the longer the baby is in the womb, the better for the baby and the better for the mum. And so having a test that will give us an idea of how quickly it will become severe or how slowly it may become severe will make a massive difference for us, the care, to the information that we give to families and to women, and how long a baby will be in the womb.
So how does artificial intelligence fit into this kind of search for platelets?
We now are using AI to combine this new diagnostic information with information about the woman. So blood tests that she's had all through her pregnancy, also her family history, and also the clinical knowledge about the woman. So we're using AI to not just combine all that information, but with new diagnostics from platelets, bringing that all together to actually give the clinician back information in real time about how her pregnancy is progressing. Not only do we have biomarkers built into AIPREMie to diagnose preeclampsia, but we also have biomarkers built in that will predict how a mother will progress during her preeclampsia. And this will be game-changing, really, for the clinician, because They will understand then when to deliver that baby, because every hour in utero counts for that baby. And one of the biggest causes of death for babies in preeclampsia is this preterm delivery. And the clinicians need more information to understand when to deliver that baby, and AIPREMie will give this information to them.
As part of their research, teams were encouraged to talk and engage directly with people affected by their work. This was a new and welcomed approach for the scientists.
It's interesting, I never spoke to a woman with preeclampsia before this challenge funding project, and it's changed my life. It's really profound to hear first-hand stories. What's really wonderful for me is I can use my training and my expertise in platelets and deliver real-world impact. And that, to me, that gets me up out of bed in the morning.
Sinead was living in Dubai at the time of her pregnancy. She's one of the many women that shared her story.
I had a fairly normal pregnancy up until a certain point. The baby reached the milestones they were supposed to reach like at each of the stages. Then suddenly, when I was about 30 weeks, I got some very severe headaches. And then 2 weeks later, I got a severe headache. I was quite nervous and not feeling well. So I went in and then sadly found out that there was no heartbeat. And I was 32 weeks pregnant and Aoife had died. And that was the first time I heard of the word preeclampsia. They brought me into the high dependency unit and I stayed there for 5 days until I gave birth to Aoife. And she was born on the 20th of December. So it was just a very, very, very difficult time. You know, if the blood test that they're now creating, if I'd been given that blood test at that point, would it have changed my outcome? You know, if things had been done differently, my daughter might be here. Or maybe she wouldn't, like, I just don't know. But you do hear of so many women and babies surviving preeclampsia that perhaps things could have been different.
Mary, if you had access to AIPREMie right now, how would it change what you do? What difference would it make?
I would use it every single day. And the other clinicians who are working on the project as well, we constantly are saying every week, I'd love to know what the results are right now.
We believe that AIPREMie will become part of pregnancy screening programs worldwide. That, right there, will be the game changer for women and babies.